Okay, I have a my main object in a blank canvas. And as all, I'll start with again dropping some background graphics to here. Of course, I have prepared the image. That's it. So although these things may look strange, may look like a robot, this is in fact a floor plan of a very simple two-gate airport terminal. And so that's this background graphics does allow me to edit on top of it. I'll lock this shape so it doesn't get selected. So this model is going to be a pedestrian dynamics model. So instead of drawing the exact paths like we did in the previous model, I will just outline the walls, and that will be it. So I'll switch to pedestrian modeling template, and I'll double click this wall shape, and I'll start. Do this 100% zoom, and I'll start drawing the outline of the terminal. Curve segments out. Okay, come to here, and I'll correct, make some corrections here. Okay, so that will be my outline, my external wall. Then I have some internal walls here. Okay, I'll define some important locations, which are the entrance to the airport terminal, and let's say, let this be exit gate A. Okay. So I have here walls and two entry-exit lines. And I'll start defining a simple process. Passengers arrive. And for the beginning, let them proceed directly to the gate. And disappear from the model. So passengers arrive where they arrive. At the entrance, they go to, we can choose this from the graphical editor, to exit gate A. I guess that is it. Let's run the model. Okay, so we defined a very simple process, and but the entities here are a little bit smarter than generic entities, because they know something about the physical space.
So look here, although I haven't specified any paths, I only drawn the walls, but the passengers would calculate this, or the pedestrians will calculate their routes, taking walls into account. So this is why they are actually going this way. And also they see each other. If you look more, slow this down. If you look more precisely on, they never, you see, they never walk one over the other, so they are actually real, let's say, physical, detailed models of people, of passengers. And you get this because you're using not the process library, but the pedestrian library, which is, just another part of AnyLogic. When would you use pedestrian library? First, when you expect some pedestrian congestions, right? Second, when you want a nicer animation of the process which takes place. Okay, so what I'll do next, I'll define some services. Services and I guess I need to draw some more roles here. All right. What I'll do. Define this barriers for the queue. Queue to check-in. I'll do the same thing here. This will be the queue to the security check. And I'll define services. This is service. This will be my check-in service. I have 1, 2, 3, 4, 5 check-in counters and 1 queue. And, okay, I'll name this service check-in. And in my process, which is here, I'll add a service block. Refers to services check-in. They let the check-in time will be uniformly distributed from 1 to 4 minutes. And let there be 100 passengers arriving per hour. Let's try this out. And I won't, just for the sake of time, I won't be defining any security check process, although I could do the same thing here. What I'll do now, and I'll add the waiting area over here, and I'll be it with the process. Like this. And here, my passengers will be waiting for the boarding at gate A. So after this was check-in, they will wait. They will wait and area gate A, and let them wait for 2 hours exactly. Because we're not modeling planes here, we're my goal is somewhat different. So every passenger will check in and wait in this area. Okay. 3D. Again, my passengers are cylinders. And I'll change that in a second. I'm saying new pedestrian type, passenger. Passenger will be in a black suit. And I'm saying that my pedestrians are actually passengers. Let's check. Too many of them, and the social force model makes them a little bit. Okay, that was it with the passenger, with the pedestrian demo. And one last thing I wanted to add to this model is this. Some of the passengers will be carrying really bad contagious disease. Okay. So, we were here in the main. In the main we have defined our layout, our process, and you know that in the process the entities are of the type, the agent type for the entity in a way is passenger. Agent entities are all the same. Now I'm going into the passenger and I'll add some behavior in here. So I'll go to the state charts palette, and I'll add a state chart for the passenger. Susceptible and infected or infectious. In the those who are aware of epidemic models know that there can be a third stage recovery, but while they are at the airport terminal, they only will have time to catch disease, but they will not have time to recover. So I will not really add this third state. So this is a transition. The only possible transition is that you're non-infected from non-infected to infected, and that will be the initial state. Okay, I will add a variable here. This is the amount of infection received. And initially, let's say 5% of pedestrians will be sick, and the value for sick for infection is 1. And 0 means you're not infected at all. So when the new passages will be created, this variable will be initialized randomly. It will be either 1 or 0, and the probability for 1 is 5%. Okay? Now, transition from susceptible to infectious is conditional, and that condition is that infection is greater than 0.5. Okay? So once the infection received by the person is greater than 0.5, he will transition from susceptible to infectious state. And while in infectious state, this person will spread this infection to other people. Let's say every second, these things happen. And here's the kind of link between the agents and pedestrians, because agents know where they are, and they know where other people are. So what I can do, I can search for other people within a certain range. So for passenger in the range 30, and in this model, this is in pixels, and 10 pixels is 1 meter. So in the range 3 meters, for all passengers in the range 3 meters, I'm doing this. I'm sending them infection if I am infected myself. Okay? And other people will receive those messages, and so I'm going to connections shape, and on message received, I'll just increase the infection by 0.01 maybe, like this. I'm done with this part of the model. Huh? Yeah. And the only remaining part is to indicate who are core infections. So what I'll do, I'll draw an oval shape with a radius 3, and I'll say that the color of this shape depends on the infection. From blue to red. This shape will be visible in 3D only, and this shape will be in 3D only. That should be it. So see here we have 3D animation, and here we have our dots. None of them are red. Oh yeah. So let's see what's happening here. Okay, so this guy, yeah. Actually this disease is too much contagious, and So the people actually can get infected, or will for sure be infected if just one passenger over here is infected. So let's, yeah, that's just too bad. Yeah, let's modify this. In the passenger, we'll say that okay, the actual impact of a contact with the infection person is not 0.01, but 0.05, like this. Yeah. All right. So that was a kind of simple combination of the process modeling and agent-based modeling, where we have the process and it's defined over a layout, but at the same time, every person is kind of active, has its own behavior with regards to spreading disease and receiving infection, and here we have a kind of result of two things combined together. Now, I'm done with the demo.